I guess I should put the light on a little bit. Okay, lights on. I'm not going to use the soundboard, but we'll check the soundboard anyway. And I'm actually going to put up my... I'm just going to go ahead and get started here. But I'm going to be listening to something. So feel free to ask questions if you come up with any. But I've got it's not a podcast. I'm listening to a book. But I've got a book to listen to. So let me go ahead and get this set up here. There we go. Okay. All right. Yeah, I'm mostly going to be working silently here, just working through some issues and see how far we get. Might have a couple more unit tests for these messages, and yeah, we'll see where it takes us. I'm going to leave the light mostly off, or maybe I'll turn this on and just put it really low because I don't want that shining in my face. And again, a reminder to all the children in the room, this is just a good old-fashioned dad's non-alcoholic bevy. It looks really cool, but it's just plant-based soda. All right. And with that, I'll go ahead and get back to it. I think this is probably coming from RPC JSON value is not a string as expected. I think I'm just gonna have to follow this to where it leads. It's probably, let's see, would it be? Well, okay, that one coming through is 0. That doesn't make sense. I'll go check that out. That's weird. Oh. Okay. Okay, so DSI collateral, keys, inputs and outputs. I'm missing acquired property. Let's look at this line here, because we shouldn't be missing TXID. Well, actually, first let's see which version of this file we have. I think we have the latest, in which case it should accept either casing, because that was a mistake that I made early on. Oh, wait. Dang it. Okay, 1127. Set number. TXID. That's weird. Huh. That's kind of strange. I could have sworn that I fixed that. Okay, there we go. So when I create raw, I do it. Eh. Oh my. Okay. Yeah, there's going to have to be a number of places where that gets updated, because It's one of those things I'm just gonna have to fix.
DMI Entertainment, how can I help you today? I'm sorry, she's out of the office today, but I can take a message if you like. Sure thing, I'll be sure to let her know. And can I get a name, please? Alright, thank you very much, Jerry. Have a nice day. DMI Entertainment, how can I help you today?
Okay, there we are. I'll go ahead and pull that over, I suppose. Hmm. Doesn't make sense. Oh, oops. Yeah, I see where I got messed up here. Oh, almost. That doesn't make sense. Hmm. Oh, cool. What? That doesn't look right. Oh. Hmm. All right, so I don't like this whole bit with the inputs being 0 there. That doesn't make sense. So let me go track that down. And I'm guessing we didn't get we didn't get the DSF because that wasn't a valid message that we sent. Yeah, okay. Let's see. Inputs dot push, huh? Ah. Okay, I see our problem here. Just a little bit of order operations. All right, that should fix that. Oh, duh. There we go. Hmm. Okay. Okay, let's see what this DSSU says. Rejected. Invalid collateral. Hmm. Okay, this is not it, but I probably need to get this. Hmm. Okay, so here's what I think is happening that made that invalid, is that I'm looping through trying to find one of the smaller of these, which is going to find ones that are denominated. So I should probably exclude ones that are denominated. So if it's not denominated, if it's higher than collateral, actually, let me think about that. I might be able to simplify this into one. I don't know if that's actually right. Okay, let's try one more time. But then we still have another problem, which is that because the barely enoughest one can get reserved, because that one we're not reserving, we're just saying, hey, this looks like one of the better ones. All right. There we go. What did I do? Hmm. Hmm. Was trying to do too many things in a single loop. There's too many conditions. That's weird.
Revelations of the dark. Thunder echoes through the night. Shadows from the distant past, drawing closer, still a banner flies. A looming storm, clouds of ash, signs of a war to come. Resurrected by a God, reigning in his soaring key. Once a spirit without hope, now his power is unleashed. It's unleashed. The face of death, a mirthless gaze. His eyes are staring right into my soul. Everything shall turn to ash. There's no hope for deliverance. This tyrant from a distant world will guide us to oblivion. A fortress in the darkened sky rises for the world to see, to dominate the weak and blind, to bind for all eternity. Time has come to stand as one. The sword of legend in my hand. Everything must turn to ash. I'll fight until the bitter end. Where hope is lost and kingdoms fall, nothing will remain. So one last time, I'll shed my blood to end this life of pain.
Oh. So I was thinking the reason that the transaction was invalid was because it's possible for the collateral that's being used for the transaction to then also be used as one of the inputs because it was not marked as reserved. So that may have actually been the case. That would have been interesting to see what would happen if it chose the thing for collateral and then broadcast the transaction, because they have to make sure that the collateral transaction was not, I guess it would put it in the mempool and then it'd put the other one in the mempool. It'd select something to broadcast and then it wouldn't be able to. That'd be really interesting. It'd be interesting to see how it handles that scenario, because you could just put up for collateral something that you're putting into your DSS, your signed transaction for the coin join, and depending on whether or not the collateral ran first or the coin join ran first, either broadcasting the collateral would fail or broadcasting the coin join would fail, which would be interesting. I imagine that is probably taken care of, but who knows. Anyway, but the actual problem was that the bytes were in the wrong format. It was hexifying hex is what was happening. So now that should be taken care of. And this whole generate or get collateral TX, which this has the ability to do other things. I actually think we just want to get rid of this. Because this is duplicate code that has now freed itself. And we probably want a get change address. Reserve change address. And so then we could just take this and do let change, whoops, equals. Yes, dash join is related to dash. It's, I can't explain it. It's too hard to explain. But it's part of the payment protocol. It's an optional part of the payment protocol. Okay, so change is equal to reserve change address. Wait. And then we'd also need something where we constantly make sure that the number of unused addresses, to do check number of unused addresses. So basically every operation that we do, we want to check that there are many, many more addresses than what we're going to need for that operation. So basically the first part of any operation should be it's not generate addresses per se, but reserve them. I never quite got to understand what you're always working on. Yeah, too complex. No worries. Yeah, so the dash stuff, it's different. There's different projects I work on, and other ones I'm more comfortable explaining. But this one, it just the explanation is very drawn out, and you wouldn't understand it at the end anyway, because nobody understands it. I am one of probably a dozen people on the planet who are now familiar with this protocol. And much like blockchain itself, it's a little bit Rube Goldberg-y, and therefore, yeah. So, but I could tell you what I'm doing right now is I'm doing it's all wallet state management stuff that I'm doing right now. So, generating a bunch of addresses from an HD wallet, so there's a wallet phrase that's used to generate wallets, and then wallets have derivation paths, and so you walk a derivation path, and basically derivation path, you just hash, you split the path, and then you hash each part of the path with the next part of the path, and then there's a bit that is used to determine whether the hash is going to be if the public key of the parent or the private key of the parent is going to be used in the next derivation. And the reason that that's important is that you can only, I'm trying to remember how to explain it, but it basically has to do with shareability. You would not want to share something that's been generated with a private key, because you can use a number of private keys to recover a key, because they're all points on an elliptic curve. And so as you're walking the derivation, you're doing an operation that is symbolically similar and has a lot of the same properties of addition. So it's, if you have a few of the points, actually I think it's just if you have one point, and there's two pieces of information that you need. One of them's pretty easy to come by. The other one's kind of hard. But if that piece of information is leaked to you, then you have access to all the other pieces of information. And so that's the difference between the two there. And then once you derivate addresses or derive addresses down at the bottom, then you could essentially say infinite. It's actually limited to 2 billion. Because the high order bit of the 32 bits is reserved for indicating the public versus private. And then the shareability. And then let's see. So you have 2 billion addresses, and so basically from one seed phrase, you can create from a seed phrase an infinite number of addresses, or at least as many addresses as are possible to reach in the hash space, which is 160 bits, I think, is what it was. 20 bytes. 20 bytes times 8, 160. Yeah. So you end up with 160 bits is essentially your address space. So I think that's the coolest thing that cryptocurrency has come up with, is the hierarchical deterministic paths. That's actually practically useful. You can have essentially one encryption key that you could use for everything in your life for all of eternity. And you pass down to generations of children. That's not actually going to happen, but it's a very simple mechanism that if we had discovered and adopted it early on, computer security might be much better, and authentication and authorization might be much simpler. So that stuff that's pretty cool. So anyway, So the problem, though, with having an infinite number of addresses is that you have to manage state and you have to check them. So the good news is that I can generate the same addresses. I can take my seed phrase and I can put it in any software and I can generate all of my addresses sequentially. But I have to then check all of the addresses sequentially to find out when one is free. It's the effing future. I don't know. I see, the problem with good ideas is that they don't generally catch on. So I don't have any faith in humanity that this will catch on. I just think that it's pretty cool. That and another thing is the N of M encryption algorithm. So basically, you could take your wallet phrase, you could generate a seed from it, which you can then use to generate an infinite number of encryption keys for anything and everything. I mean, you could give anything that could be digitally addressed, you could have an encryption key for it. You have to have a catalog for it, and you'd have to back that up. But I mean, you could just brute force, because you're not going to have enough digital things in your life that you wouldn't be able to just try every single key that you could possibly generate within the bounded space of the number of things that you could generate keys for. In your lifetime, you're going to have hundreds of thousands of things. Maybe, you could iterate through hundreds of thousands of keys, and then you can eliminate them. And anyway, so yeah, that's actually, it's good, but I don't think it's really going to catch on. In general, it's not profitable. In today's marketplace, where nobody has a product and nobody has a customer and everybody's just playing investor hot potato, it's not profitable to have something that works well and is sane. You need to be building things. You need to show that you're building the future. So if you use any existing technology that's not connected to the investor's portfolio, then you're not, it's just, yeah. I want to get into cryptography, but my boring jobs that pay bills do not allow me to do hobby things. Well, I mean, do you not have any? I don't buy that. Sorry, I don't buy it. I mean, unless your boring jobs that pay bills don't have any programming, but then still I don't buy it, because the whole point of programming is that you can fix things and you can automate things. So whatever your job is, I think you need to be a little more creative. But then again, I don't know. I mean, if you're a carpenter, then maybe. No, didn't you say you're an ENT? What are you right now? What are you doing? Anyway, I think there's more opportunity there than you might give credit for. Anyway, so reserve changes. Oh. Okay. So I'm probably not going to stay on too much longer because I need sleep. I didn't sleep last night. And I got up nice and early this morning. Well, nice and early. I got up around 11. Well, 10. 9? There was a lot of in and out. Okay. So let's see what's going on here. My goal was just to get the DSF. That was my hope. If I get the DSF, then I've had a really great day. The DSF is a message in the protocol. So DSQ comes through. You're a dev full time. Yeah, if you're a dev full time, then that's BS. You should be getting into cryptography, and like the fact that you're not doing it really just goes to show that you aren't doing you're not doing the R&D part of your job well enough to know where it applies, you know? So that's my feedback. Okay, so address 522 change dot address. Okay. Where did change come from? Reserve change address. Reserve change address. Reserve change address. There's no way that we looped through all of the addresses and we didn't find any that were available. That's not possible. Minimum unused addresses at any given moment should be 500, and then we run this. Basically, anytime we're going to use addresses, we run the minimum unused and then top off. By the way, if you haven't had a Dad's Root Beer and you can get access to a Dad's Root Beer, you deserve a Dad's Root Beer. Okay. Yeah. I used to drink this stuff when I was a kid, and I was thinking about it one day, probably because I was talking about video games or staying up all night. Because me and my buddy Mike Barker, we used to be over at each other's houses. We'd have some Dad's Root Beer, and we'd stay up playing Final Fantasy or Mario or Star Fox or whatever it was. It was the Nintendo 64 era. We'd stay up until the bats come out in the morning. So we'd go out around 4 or 5 a.m. as the sun was starting to rise. Oh man, being a kid was great. Except for he always was pretty brash, or not brash, rash. What I'm trying to say is he would get upset with me and then he would delete my memory card. Well, he would delete my game save file on his memory card. And he'd get upset with me over dumb things, and so I've never finished Final Fantasy VII. Because I've played the first disc a lot of times, but I know the spoiler. I'm very upset that I know the spoiler. Somebody talked about it on the bus one time, and then of course, since then, YouTube was invented and people talk about it a lot. But I'd like to pretend that I don't know the spoiler. Anyway, I have to figure out why reserve. How is this possible? Reserve change address. Change for address of addresses, blah, 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 blah. If not used and not reserved, then it's available. Be used as change. In which case, See, but this every address, you have to know which wallet it came from, which you know by the ID. The wallet itself is a secret. The wallet phrase is a secret. And the wallet phrase is used to generate the wallet seed. And then the wallet seed is used to generate the wallet ID. But then the wallet, you derive from the prefix, and then you have your account and your usage and your index. So these are the three things that are variable. This is actually just the one is for testnet. I gotta remember to change that later. Anyway, #1 root beer rating by Taste of Home magazine. Is that true? Or are you just are you toying with me because I was being nostalgic? Because that could be real. I'd also highly recommend Hank's and Henry's. Okay. Taste of Home. Going to the home page. I don't see anything about root beer. Do they have a search? Root beer. Best Dyson cordless vacuum cleaner is the first result when I search for root beer. So I'm going to say AI is going great. I see they got some Outerberg. They've got one of those. I don't see it. Oh. Dad's root beer homepage. Alright, I'm going to Dad's root beer homepage. Oh. Well, it's funny that Taste of Home doesn't have that on their website. Ew, diet. So gross. Yuck. I ought to try the Dad's cream soda. I think they have that at Cracker Barrel. You can get this stuff at Cracker Barrel. I know they've got the orange and the blue cream soda. I think they've even got the red, but I think they might have Dr. Wells as well. But I don't remember if they had the plain cream soda or not. But that's something I ought to check out sometime. Thank you. Okay. Anyway, let me. How is okay? What is going on here? How could I possibly be getting this error? This error makes no sense. If I can scroll back to where the error was there. Okay, can we get undefined reading address? All right, so let's check this out again. Get collateral TX 522. Okay. 522. So this one right here. Set number. Okay, so change is created right here. Is assigned here. I don't get it. Okay, there's something wrong with my logic here. If... So, is available means it's not used and it's not reserved. So if it's not available, exit out of the loop. All right, here we go. So, all right, let's try. We'll all run it again. All right, let's in the next 15 minutes, let's get the DSF message and get and blow this joint. It's got a 15-second timeout. DSSU. I need to have the DSSU in a loop. We also need to check that DSSU to see if it says accepted or rejected. If it says rejected, I'm just going to have to pick that up tomorrow. I could probably look and see. Do we print out what the message or what the collateral looks like? Because I could decode that and just quickly see is something way off. So it says it's ready. All right. Okay, I think what happened is I think we got rejected. Let's go check out the DSSU. So it should be this whole thing right here. That data comes in. Does Telebit do the same as Ngrok? I don't know. Ingrok has changed its business model a lot over the years, but at one point they were similar. So I don't know what Ingrok does these days, but yes. I started Telebit before the rise of Ingrok, but never really made it popular. I think originally Ingrok was actually a tool that I wish existed, because I think originally what they were doing was a network grok tool. So the idea of the proxy wasn't necessarily the tunneling as much as it was being able to sniff the headers and the connection details and be able to understand what's going on. And then that was the name, and then it transformed into the tunneling tool. And I think their original version might still be on their GitHub as free, but yeah, I think now they're doing a cloud kind of thing. I'm not sure, but I think they pivoted again. So I'm not, but yes, around Ngrok version 2, Telebit, or maybe it was 1.0 out of beta. I don't know. In the early days, they were very, very similar in the ability to tunnel a connection. Telebit was for encrypted connections, and I think Ngrok got the Let's Encrypt and that sort of integration later. Okay, so let me see here. Okay, so the first thing I need to do is go into my fixtures and my DSSU and just... Okay, yeah, it looks like these two messages are Diffner. So let's see, what do I get when I run test DSSU? Error maximum. Interesting. Error maximum. Oops. Why doesn't it just select some? All right, let's find out what error maximum is about. I kind of, this is good. I can tone it down a bit and we could get past that error, because I kind of intentionally got that error to a degree, because I wanted to see what would happen if I tried to put forth 19. I don't know what the maximum is. Be nice if there's some documentation for that, but alas. What is the DSI? What's the maximum number it can have? I don't think it's set a maximum. DSF, yeah, okay. I'm going to go look that up in the source code real quick, because I would like to know. What is the maximum? Okay, let me... Is it here? I don't know. I don't know if Telebit would be better than Ngrok or not, because I haven't really looked into Ngrok lately. And I haven't been developing on Telebit lately. Let me just Telebit my local webpage. How does it look on your PC here? Grab the link. Yes. Yes, that is the goal. Entry exceeds maximum size. Okay. What is the maximum size? 9. 9.
And I promise you'll never see the loss of me.
Okay. So there's a lot of arbitrary things in here that I just don't like. Why you gotta go and make limitations so arbitrary? See what I'm saying? Oh, whoops, that's not what I wanted. I wanted, was it V20.x? V19.x? That'd be fine. That's not going to be updated anymore. It's not a working version anymore. Okay. All right, so now, come on, baby. Last time's the charm, right? This is the money shot. Give me the DSI. I know it. DSF. Woo! All right. That is our DSF, baby. DSF. All right, so I'm just going to put this DSF in our fixtures, and we will parse it tomorrow, baby. We are so close. We are so close. That's an excellent note to end on. Bless me. All right, so I'm going to go ahead and add dev RPC, get status, fix, various, like, okay, what is this one? All right. Simplify state, use hex / bytes. Lower max inputs. Get DSI. Or DSF. Get DSF. Cool. Boom! So we are literally one step away at this point. Well, depending on how you count. We need to send a message back that signs. So we have to parse the DSF to get the input information out of it, which should be relatively simple. I don't think it's going to be a huge issue. I've done this parse. It may be involved. Let me go check and see. It may be involved, but I've already done this parsing before. It's not exactly the same, if I understand correctly. Let's see where our DSF falls. DSF. All right, I'll take a look at the DSF. Okay, so DSF has a final transaction. Okay, so I have written the parser for this. I don't know if I've exposed it before, but I've written the packer and the parser for TX messages. So this is going to be a raw TX. So I wish that they would designate, it would also be nice if the documentation would always distinguish between different types of TX message, because there are a lot and they don't follow the same rules. We don't just shove all DS star messages under the heading DSTX. Instead, we name each type properly. Likewise, knowing if a transaction is raw or signed or is a request or unsigned or signed, etc., would be hugely helpful in understanding. Would be hugely helpful. Okay. All right. So, okay. So it is just a transaction message, but it is, I don't know what form it's in. It might be raw or, let's see, if it's, is a, TX request, hashable TX, or signed TX. There we go. All right. So my guess is that this is, well, that essentially there's a type of transaction that is more a request. What it is it's what you use to tell your wallet to fetch keys, and then it spits out something entirely different when it signs it. And then there's an internal representation. I think the only representations of a TX that you encounter are what I call the request, because it doesn't have the information that's necessary. It just has, it's a request. Like I said, it's a request. It poses the question about the coins, but it doesn't contain the answer. And the final one has all the answers. So anyway, this message is going to be sorted properly. Yeah, so, oh. Message header has been omitted. I actually don't like that. Session ID, I'm not really sure why we have that. I guess it's because the whole pretending that we're not using TCP thing. All right, number of inputs. Okay, yeah, signature. So these are null sigs. So I think these are considered null inputs. So what we're going to do is we're going to send back a transaction that has all the null, we're going to go through all of these and we're going to fill out any of the ones that we have keys for. So we're going to parse this. We're going to iterate over the keys. We're going to figure out which ones we have keys for. And then we're going to change the signature type. And then we're going to put it all back together. Now, this is going to require some edits to -tx, because -tx right now is not meant to handle the case where you have inputs that you don't sign, because we haven't come up against that case yet. But it's not going to be world changing to get that working. There might be a little struggle bus in there, but it's not going to be. It's known. It's known quantity. So then we got the number of outputs. And then the outputs don't have anything special about them. Basically, what happens, this may already work. Because all we got to do is take the signature, get the intermediary representation. I might be taking some functionality that's in there and just splitting it out. Because basically it's the hashable representation. It already works like this, kind of, where you null out the inputs that you're not presently signing. So you don't sign the other signatures. So yeah. So I think that basically what we're going to do, let me see if I remember this correctly. We null out all the inputs. Yeah. Okay, so we may be able to use this directly. Maybe we can use this directly. Do we have to parse it, or can we just... I have to look at it. I'll have to see. Yeah, we should parse it. But we may just be able to use this directly because this is already all the null inputs. And so all we do is we get the hash, which, do they give us the transaction ID? Because that would be awesome. Because if they gives us the transaction ID, then literally No, okay. Wait, I think I know what to do here. I think I know what to do. I think we can totally shortcut this. I don't think we have to parse it. I think that because this TX final is already in the null form, and the null form is the form that we need to hash. Right? I think that's right. And so we hash the null form, and then we sign that, and then we put back our signature. No, we do have to parse it because we got to reconstruct it. But we do that for each input. We sign the null form with each of our inputs. Then we reconstruct the transaction, if I remember correctly. It could just be sending inputs. Let me see. What's the DSS? The DSS, do we just send inputs? Okay. Oh, yeah, sweet. Yeah. Oh, no, this is going to be, I mean, like famous last words, but this is going to be cake. This is going to be cake. All we got to do is take that TX, hash it, and then sign the hash. I thought, so when I was explaining this to Ryan earlier, I thought that we actually had to parse out each of the inputs and then do the rigmarole on them, and then sign it and then publish the full transaction. When I was talking about the with JoJo, I was explaining it more complicated the way that I thought it was working. But if I'm reading this correctly and if I'm remembering correctly, again, there could be some snags in there, but in the DSS, we don't have to send back a signed transaction. We only send back signed inputs. So all we got to do is change the signature type. That's super easy, barely an inconvenience, not even an inconvenience. I'm pretty sure that code's already there. We may not have to make any modifications to -tx whatsoever. This may be the easiest day yet, because we already have the DSF. All we got to do is hash it and sign it. And I might have to pull one method out. You know, let's just go take a peek real quick over here in -tx. All right. We have hash and sign all. We would need basically a hash and sign one. Let me take a look at this. So we're going to take last TX to transaction, target fee, but we're not actually going to do anything to the target, right? Oh, no. Let's get away from that. Hash and sign all. Where's the hash and sign all? Okay, hash and sign all. Sort the inputs. We don't have to sort the inputs in this case. Okay. So your private key, throw. Okay. All right. So this is for each input. So this we need to pull out into its own function. That's where the work is going to be. We just pull this out into its own function because we're not going over all the inputs. We're going over the inputs that we have. So yeah, we basically need to have a sign input function. So we have a hash and sign all function. And I think at some point I was trying to figure out how to do an individual, because hash and sign all is kind of big and it's doing a lot of stuff. But I didn't understand the constraints well enough. And so it's just like, sometimes your loop's a little long. So it's 50 lines long, 60 lines long, 55. That's big. I tell people, don't do this. Your loop should be really short. If your loop needs to be long, put it in a function. In this particular case, there's a lot of state, yada, yada, yada. But, okay, so we are not going to hand back. Okay, so we have to modify this. We have to pull it out into a sign input. So rather than a hash and sign all, we need to have a hash function, and we need to have a sign one function. So those are the two functions that we're going to have to pull out of this. All right, create hashable. So the hashable, I believe, is the one. Let's see. If we go to create hashable, TXIDs, output index, and then, I mean, I guess it could have had a lock. Let's see, what does it say here? Create, return, hashable inputs. Okay, underscore create equals. I don't like the complexity of this, but, you know, it's one of those things. Okay, so pack inputs. All right, that packs all inputs, but we need to, we will need again to figure out, can we pack just one? And no, we have to pack inputs. Let's see. What does this look like? Let's look at the DSS again real quick. Because I think that one, well, the DSS, we actually don't need that final. Okay, let's go look at the DSS again real quick. All right, DSS message. Inputs, TXN, sign input for the session. Must be signed, blah, 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 blah. User inputs. Okay, number of inputs. So we do pack inputs. Okay, so we will pack inputs, but we'll only, but it's a little weird. It's a little weird. Because, okay, so let me get back to... okay, we're going to go back. TX hex. Okay. Underscore create. Let's go back to where we're looking at. So create signed. Wait. Where's the signing part of this? There's no signing here, is there? Pack inputs. Is there a signing? Oh, now I remember. This, if there's a signature, so we need to find out what generates the signature. Signature equals signature. It's like the sig hex. Okay, so where did sig hex come from? It came from right there. Where'd sig buff come from? Okay, tx hashable, hash partial. Okay. TX hex. So that's it right there. That's sig hash type. And then this is what we use. So we're going to do TX hash partial. Okay. So we're going to take in the whole TX final. We're going to do a hash partial on it. Because the hash partial, that's the thing that we sign. Let's see, do we have another? Is there another time we use the hash? Because there might actually be different hashing algorithms that we use. I have to double check. Get ID. Okay, so get ID is different from hash partial because hash partial, we also include the sig hash type. Whereas with the ID, we don't. Hence it's a hash partial. Got it. Okay, yeah. So we hash it with the sig hash type of the input. So for each of our inputs, we hash it with the sig hash type of our input. We attach that signature to our input. We pack those inputs. Boom. Done. It's going to be a cakewalk. All right. On that triumphant note, good night to you all. I wish you sweet dreams. I'm really excited for tomorrow. Okay. I can't believe I'm saying this. No, I'm not going to say it. Not going to say it. I was typing in the chat. I was going to say this is going to be cake.
For days I was lost without reason. I walked with the changing of seasons. Searching the world for my past. I have found
Transaction. Okay. All right, cool. I'm out. Thanks, Vitals. I'll catch you later. Adios.